laws of motion. Let's review some of the things we've learned so far. Force can be described as either a push or a pull on an object. Friction is the force created when two objects move against one another. And there are invisible forces at work all around us, like gravity, electromagnetism, and nuclear force. So how do we know all these things about forces? Well, scientists unlocked the mysteries of force so that we could understand how they work and how we can use forces to our advantage. One scientist who did important work with forces was Sir Isaac Newton. It is said that in 1687, Newton came up with his theory of gravity when he saw an apple fall off of a tree. Newton also came up with 3 laws of motion regarding force in the world around us. Newton's first law of motion states the following: an object at rest will remain at rest, and an object in motion at a constant speed will remain in motion at a constant speed until some outside force is applied to it. Let's take a look at a real-world example of that law. Right now, this bowling ball is at rest, not moving because the forces acting upon it are balanced. The ball will stay at rest until the bowler pushes the ball down the lane, creating an imbalance in the forces. Now, if no other force acts upon the ball, it will keep on rolling forever. Luckily, the friction between the floor and the ball, the force of the pins, and the wall at the end of the lane will help make sure that doesn't happen. Newton's first law is also known as the law of inertia. Inertia is the property of matter that causes an object to resist a change in motion. So what determines an object's inertia? It is the object's mass, which is the amount of matter in an object. The more mass an object has, the greater its inertia. That would explain why it's easy to move a toy car with a simple push, but very difficult to set a real car into motion simply by pushing it. That brings us to Newton's second law of motion, which is expressed in the form of a mathematical equation: force equals mass times acceleration. First, let me explain acceleration. When you think of acceleration, you might immediately think of things going fast, like race cars speeding around a racetrack. But acceleration is actually any change in an object's direction or rate of speed. So even an object that is slowing down or stopping is said to be accelerating. Newton's second law of motion tells us that the acceleration of an object depends on the object's mass and how much force is applied to the object. When you take a billiard ball and hit it with a cue stick, you are applying force to the ball. When you apply force to the ball, it changes speed or accelerates and shoots across the table. Now watch what happens when you exert the same amount of force on a bowling ball, which has a lot more mass than a billiard ball. It doesn't travel as far or as fast. Remember, we said that the greater an object's mass, the greater its inertia. And objects with greater inertia require more force to accelerate than objects with less inertia. That example demonstrated the role mass and force play when it comes to acceleration. And there's one more important thing to know when it comes to acceleration. When you apply force in a certain direction, the object will always accelerate in the same direction. Like if you swing your foot forward to kick a ball, the ball will also go forward. An object will always accelerate in the same direction of the force. For example, when you hit the ball with the cue stick, it will travel in the direction that you hit it,